Hello, AP Stat students, back here for the second data analysis lesson. Again, the first data analysis lesson was about the 5-number summary and outliers and box plots. And so we talked a lot about median and IQR. We're going to talk about a couple of other uh, summary statistics, so types of ways that you can define a data set. So median, obviously, is a measure of center. IQR is a measure of spread. Okay, another measure of spread would be range, biggest number minus smallest number. And those are statistics, particularly median and IQR, are statistics you like to do when the data like to use when the data has outliers. Or stretches much more in one direction from the median than it does in the other. Whereas mean and standard deviation, which we're going to talk about here, are statistics that you like to use when the data is symmetric, and we'll get into that here shortly. So mean, same as always, you add them up and divide by how many points there are. This is even on your formula sheet for the AP exam. But again, mean is just the average, so it's just you add up all the values and divide by how many values there are. In order to use your calculator to find the mean, you would again go with a stat edit, and that would put the values into a list for you. That will bring you to the list, and you can put the values into that list. And then again, from there, you can quit and go to stat calc. So if you go to stat calc after you put your list in, you go to stat calc, one variable stats. That will allow you, if you put the list, whatever list it is, list one, frequency, you can leave it empty and calculate. And the X bar value is your mean. So it'd be the top value that you get in your one variable stats. Now, when you think about mean, what you need to think about is when does it make sense to use and when it doesn't. And here's an argument for where it kind of falls apart. If you think about what is the average salary of a McDonald's employee, a lot of folks would say it's somewhere around 20,000 or 15,000 or 25,000 or something like that. When I would argue that it's actually probably more like 75,000. And again, the reason I would argue that is if they're a McDonald's employee, that would include the CEO and all of the upper management positions. And so you have a bunch of folks kind of in one bucket down here making somewhere between 0 and 15K or 25K. And then all of a sudden you have this little bucket over here of people making way more than that. So the average ends up falling somewhere in here, which again, there might not be a single employee who makes within 2, 3, 4, 5,000 of the average salary for a McDonald's employee, or hourly total take home for a year. And so the mean has times where it does not really make sense. And this is a situation where the data is very unusual. This would be considered kind of a bimodal scenario where you have a really comprehensive or complete group over on this side over here with a lot of folks in that bin. Then you have a pretty empty space, and then you have the few that make a hefty salary at McDonald's. So that's a situation where mean might not make as much sense. Another spot is in Minnetonka. Our median home value in Minnetonka is about $333,000. But if you think about our school district, I would argue that our average home value is probably closer to around 700,000 because of, if you think at least our school district, because of how many homes we have that are on the lake and things like that, where they cost a lot more. And what happens, and this is true in a lot of economic situations, is the distribution actually looks like this. Okay, and what this is these homes over here, there we go, these homes over here on this end are the multi-million-dollar homes. And so there's a few of those that drag this out. Most homes are in this area, which is about the 300 to 500,000 maybe area, or 250 to 500,000. And so those values, there's a lot of values there. So the median in this situation, The median's probably about right there, which would be the 50th percentile. But the mean in this situation is probably somewhere out here. And so you just have to determine what do we want to argue here. If our district wants to make it sound affordable to live in our district, then we're going to report the median out in any sort of marketing materials. If we want to make it sound prestigious or whatever, super affluent, then we're going to report the mean, because that value, it's dragged up by these outlying values over here. So you can see the mean has this is influenced pretty steadily by these values up at the high end, whereas the median is just going to sit at that 50th percentile either way. Now, the mean is the measure of center. Standard deviation is the measure of spread. Okay, so this measure of spread works really hand in hand with the mean. They both struggle with values that are extreme in either direction. But this measure of spread has to do with what these are right here. These are called deviations or squared deviations, since I included the exponent there. But this represents each individual value in a data set. This represents the mean of that data set. We won't jump into why this is n-1 here instead of n, but it's basically, on average, how much does a value deviate from the middle? Now we square right here and then square root here in the name of getting all the values positive, so that since the deviations will always add up to 0, because the mean sits in the center of all these values. So for our work, we're probably going to, again, stat calc and put in a list of numbers, and then exit out of that, and then stat edit, not stat calc there, stat edit, put in a list of numbers, then get out of there and go to stat calc, one variable stats again. And in this case, we're now looking at S sub x. That's our standard deviation. And again, that's in the one variable stats. And what your calculator is doing in that situation is it is in real time taking a situation where, let's say our first value is 3 and our second value is 5, and let's just say that this is the third value instead of the nth value, and let's say that's 7. So what it would do then, in this case, the mean of this situation is 5, 3, 5, and 7. The mean, or the x bar there, would be 5. So it would be the deviation of 3 minus 5, or -2, a deviation of 5 minus 5, or 0, which is, again, x minus x bar. And then the third value is 7 minus 5, which is 2. Sorry, that's -2. And so this sum will always be 0, okay? And that's because the mean is in the middle, so the deviations will always be 0. That's why we square. So -2 squared is 4, 0 squared is 0, 2 squared is 4. So this has a sum of 8, okay? And then that 8 divided by n-1, which is the number of values in the set, which is 3 here. So that's 8 divided by 2. So the variance in this case is 4. Now, variance is just standard deviation squared. So if you recall, the formula looked like this and had the radical over it. Before we have the radical, that is the variance. And so the standard deviation here is just the square root of the variance. So that would be reintroducing that radical into this situation. And this square root then would be the square root of 4, which is 2. So it would look like this. S squared here is 4, S is 2. And of course, it's very unique for these to actually be whole numbers, but they happen to be here in this situation. But this process here is one you will not be asked to do much at all, because we'll rely on that stat calc. What you need to understand more about standard deviation is some of these points. We really use, as I mentioned before, standard deviation with mean. It should be utilized when the distribution is symmetric. And by symmetric, we mean something maybe like this, where it's this bell curve, or even something like this is symmetric. These are situations where we would most likely have no outliers, okay, or no real influential values. And the standard deviation is non-resistant, which we'll get to here in a moment. So if a data set is skewed or looks like that economic one, the home values, then we're going to be more likely to use the 5-number summary or just some sort of graph to give us the better picture. And with this here, in this idea of being resistant versus non-resistant, if you think of this simple data set here, 1, 2, 3, 4, 5, 6, 7, forget the zeros there at this point. Right now, the mean of those values is 4. So x bar equals 4. The median of those values, which is the middle value, is also 4. The standard deviation here, which is S, is about something like 1.5. The IQR here, well, if this is the median, then IQR is, Q1 is the middle of the bottom and Q3 is the middle of the top. So IQR is 4 here. And the range, which is the biggest minus the smallest, is 6. Okay, so now if we were to change 7 to 7 million now, okay, so now we have an outlier. Okay, so this started off as a perfectly symmetric distribution, 1, 2, 3, 4, 5, 6, 7. Now all of a sudden we have 1, 2, 3, 4, 5, 6, and then we have this 7 million that's way, way down there. Okay, obviously much further than I drew it there. That's an outlier in this case. In this case, it's symmetric. This would be skewed. And skewed just means that it's not symmetric, really. In this case, we'd call it skewed to the right because we essentially go with the direction it drags out here, which is to the right. We'll talk more about skew later on. But when we look at this here, now the new mean is about 1 million, okay? The median is still 4. The standard deviation is about 1 million. Excuse me, 1.5 million. The IQR is 4. The range is almost 7 million. So what you're seeing here is resistant, in this case. Resistant is the median and the IQR. Those values resist outliers. And if you, remembering resistant versus non-resistant, the actual terminology is not as important as just remembering that median and IQR are great to use when we have skew, okay? When we have something that's not real pretty in terms of values, like professional baseball salaries, for instance, you'd want to use median and IQR because most guys make about $500,000 to $1 million, but some guys make $30 million, okay? Now, mean and standard deviation really go hand in hand as our non-resistant, values that we like to use when it's symmetric. Okay, so here we like to use mean and standard deviation. And again, that's because you can see what one value here, when we got this 7 million, that just blew up the mean and the standard deviation. So now the mean is 1 million, but we don't even have a value close to 1 million in this data set. So we don't like to use mean and standard deviation in these situations, but we do if it's originally the 1, 2, 3, 4, 5, 6, 7, because there the mean is 4 and the standard deviation is 1.5. And the mean actually gives us more information because we could work backward with the mean and figure out what the sum of all the values are and things like that. Now, range is a weird one. Range is also non-resistant, okay? But range is just so easy to find that we tend to use it often. But that's something to just keep in mind, that range goes along with standard deviation and mean as non-resistant values, meaning they can't resist the temptation of outliers, whereas median and IQR can. And that will affect what statistics we use when we start to analyze a data set moving forward. Thank you for listening. If you have any questions, please just let me know.